Section 6.1, Chapter 6. There are two types of random variables. One was discrete variables, and the other one is continuous variables. The discrete is what we discussed in Chapter 5, and this is an example of that X is the whole number of patients who walk into doctor's office on Mondays. So nobody walk into doctor office, probability is 0.10 or 10%. One person, 25%. Two people, 35%, and so on. So for discrete, the value of X is whole number, because you're talking about number of people. And the graph is always a rectangle. So in that case, probability always has to be positive, is always between 1 and 0. Now, on the other hand, we talk about continuous variables. Continuous variable, like this example, temperature on Mondays, summer of 2022. Temperature can also take the decimal number. As you see, the value of X is whole number and also the decimal. So between 0 and 1, it should be so many numbers. Even you could put a number between 0.1 and 0.2. It could be 15, 0.16. So in that case, you don't have a rectangle anymore. For every single point, if your vertical axis is probability and your horizontal is X, then you have all these points that create a curve. So the rule is sum of Px still has to be 1. That's one of the conditions that we need to have, whether you have discrete or continuous. It just in this case, to calculate the area is not as easy as this one, because here you just find the area of rectangle, but here you see at the top there is a piece of curve. So for that, we have introduced some tables, statistician introduced some tables that you could actually calculate area under this piece here. We also have uniform distribution. Uniform distribution is a special case of discrete. See here, you see all the probability are different. What if all the probability are the same? Like when you roll a die 6 times. When you roll a die 6 times, the first time, what's the chance of getting number 1, number 2, number 3? They all have equal chance of occurring. So in that case, the probability remain the same. This they call it uniform distributions. Normal distribution can have any mean and any positive standard deviation. A standard normal distribution has mean is 0 and a standard deviation is 1. It follows a nice bell-shaped curve. Non-standard normal distribution can follow bell-shaped curves that are tall and thin, or short or fat. This is normal distribution. You see it's a bell-shaped curve, and if you draw a line, vertical line through the mean, is a symmetric. These two pieces, the area under the curve is always 1. So if you split it into 2 equal pieces, each piece is 0.5. Curve is the bell shape and is symmetric. Now, there is a special case. They call it a standard normal distribution. A standard normal distribution is in case that a standard deviation is 1 and mean is 0. In that case, the horizontal axis we use as a z. And all the tables that you see on Chapter 6 are based on a standard normal distribution, because the normal distribution can have so many different numbers for the mean and the standard deviation. So if a standard deviation and mean are a different number, that's the normal. But the special case is when the mean is 0 and the standard deviation is 1. So in case that mean is not 1 and the standard deviation is not 0, which is a case like that, then we do have the conversion. This is a formula for conversion. Means if we give you the value of x rather than z, you have to use this formula to do the conversion. As we go through the examples in the future, you understand how to deal with this formula. And this is a uniform distribution. In uniform distribution, it's very easy to calculate the area under this line, which is the rectangle. You see how if you have a histogram, if you connect the top point of all these rectangles, then you see a bell-shaped symmetric curve. The center is always the value of the mean. Now, this is a uniform distribution. And let's say I want to calculate probability of px. To calculate the probability of x less than 4. Probability of x less than 4 means you want to calculate this area, shaded area with red color. In that case, we know the total area must always be 1. So if the probability is 0.2, if the vertical is 0.2 and this distance is 4, to find the area is 4 times 0.2 or 0.8. 0.8 is the probability of x less than 4. Or how do I calculate probability of x less than 0.7? Point less than 7 would be this area that you cannot use the hand calculation because this is something that has to do with the calculus. So for that, we have some tables that would calculate for you this area in case of the curve, which is a continuous. That's why it's a decimal number. This is examples that area of this rectangle must always be 1. In order to have 1, if this distance is 5, then the vertical distance must be 0.2. Why? Because then when you multiply, the outcome has to be 1. In these examples, question is, find the probability of at least 2. At least 2 means you go all the way from 2 to 5. So the question is, find this area. To find this area from here to here, the distance is 3 and the vertical distance is 0.2. So area of this rectangle is 0.2 times 3 is 0.6. So what is the probability of at least 2? Answer is 0.6. So for a uniform distribution, area is always height times the width. So if this distance is given is 2, and we ask you to find the height, you know the multiplication is 1. So then this should be 1 over 2. If this length is 0.5 or 1 over 2, then 1 over 2 times 2 would give you area of 1. So we know area always is 1. And if we give you the distance of horizontal and ask you to calculate that, that's how you calculate. This is an example of the discrete because you have a whole number here. And what's the area of x greater than or equal to 2? Means you find area of these two rectangles. So that would be area of this rectangle plus that one. That shows you how to do calculations. Or what's the probability of x less than 3? Means you want the whole area. In that case, you have to calculate area of each rectangle and add together. This is in case of the discrete. Again, in case of discrete, because you're dealing with a rectangle, it's easier to calculate. Now, this is an example of continuous. What's a probability of z is less than, for continuous, you have a curve and the horizontal distance is a z. Remember, this is a special case when mean is 0 and a standard deviation 1. They call it standard normal distribution. So in that case, if I want to calculate z less than 1.27, the mean is 0, so which is in the center. 1.27 is somewhere here. And if I want to calculate this yellow, then through the table A2, you take this 1.27 and separate it into 1.2 plus 0.07. 1.2, you find it from this column, and 0.07, you find it from it. That gives you the area is 0.8980. And if you want to find the remaining area, if you want to find this area, then all we need to do is subtract from 1. Why we subtract from 1? Because the total area under the curve is always 1 or 100%. Remember, table is one method to calculate that, but then we show you how to use the calculator that is way easier than table. But I need to let you know that table is one option that you could actually find the area or probability. These are different situations that you have here based on that examples. Like what is area to the left? In this example, we want to find probability of z is less than 2.08. So you could either go to the table A2, which is at the end of the textbook, and find this, or as I mentioned, it's easier to use a calculator. If you want to use a calculator always give you the value from that point to the left. Means calculator always give you the area to the left. So z is less than 2.08, means I want to calculate this area. You go to the second verse, normal CDF, and then the calculator need two end. One end is 2.8. The other end we don't know yet, so you always can use the arbitrary number. The reason we do that is this. A standard curve, mean is always 0, and here is, we just say z, z is 0, which is the mean. Now, as you go to the right, when you reach to z equal 2, we are almost getting really close to the end of this curve. Like if I say value of z is 10, that means you're almost touching this area. Or if I say z is equal to minus 10 or minus 20, means you are somewhere here. So you see the area is almost getting to the 0. So when you are working on the problems, since the calculator always need to end the point, when we ask you to find area to the left of 2.8, one end is 2.08. For the other one, you could always use a large number like minus 10. Why is minus? Because you're talking about that give you the value. So on your calculator would ask you the lower, which is this side, ask you for the upper, which is this, and that give you the area. It give you that number. What if we ask you to find area to the right? In that case, all you need to do is, since the calculator would always give you this area, and you know the total area is 1, you could subtract it from 1, that give you the area of this. It depends what the sign is. Z is greater than that, means they want to find this area. Then the total area 1 minus that. Either that, or the other way to do it is on this normal CDF is need to end. You could just say, okay, one end is 2.08. What's the other end? Just use positive 10. That's another way to do it. So there are two ways. One is calculate this area, subtract from 1, or on your calculator, since calculator need two end, one end is 2.08, the other one is just positive 10, that give you the area directly. You don't have to go through that. In this one, find the area when z is between positive and negative. Again, both ends are given. So on your calculator, when you put z1 and z2, if you put these two numbers on your calculator, you have the area. So you don't have to worry about the table anymore. Z is greater than minus 1.75, means they are looking for this area for the probability. So one end is minus 7.5. What's the other end? 10. Arbitrary number, 10. It could be any large number, 10, 20, 100, still come up with. This is area of here. And then, now, what's the probability of 99? Probability of 99 percentile, or probability of 10. P of 10 means 10 percentile. Means these, in these examples, they are asking you to find the value of the z. Means is vice versa. When they say find the percentile of 99, means you have the area of 0.99. Find the z value. In that case, you could either go to the table, these numbers is the probability in the table, which is the area. You could either do that, or the easy way is to go on your calculator, and you want to do it backward. You have the area, you want to find the z. So in that case, let's say here, you go second verse, and then inverse norm. Inverse norm means give us the area. Area is 0.99, and you don't change anything else. And then that give you this number. It give you a z value. Okay, so that's how to find the z value if you know the area. What is the probability of 10%? 10 percentile means the area here is 0.10. Remember, the total area under the curve, on the standard curve, the total area is 1. So this is 0.50, and this area is 0.50 because total is 1. So when we say find probability of 10 percentile, means 0.10. Where is 0.10? It's probably somewhere here. This area is 0.10, 0.10, 0.20, 0.3, this, the whole here is 0.50. So probability of 10 percentile means the area is given. Just find the value, which has to be positive, because remember, z equals 0 is in the center. But as you go to the right, z is 1, z is 2. And when you go to the left, z is -1, z is -2, and so on. So this is a negative part, and this is a positive part for the z. So you go to the second verse, inverse norm, you put this area pointed, that gives you the z value for that point. Now, in this one, bottom is 2% or 0.02, at the top is 2%. These are two tails. In that case, both tails are normally equal. When you have a problem that are two tails, both tails have equal area. So z of 2%, when you do that one, it gives you minus 2.05. The other one you don't have to calculate. If this is negative, the other one is identical with a positive. So when you have two tails, these two numbers are equal and opposite. One is positive, one is negative. So we just need to find the z for that area. Now, this is instruction of the calculator. If you want to find the probability, that's how to use it. If you have the area and you want to find the z, that's how to do it. Now, examples. I think the page number 1 I have the solution for you here. The first two are multiple choice, and then here, the waiting time between a subway departure schedule and arrival of passenger are uniformly distributed. Means this is a case, and they want us to calculate probability of x greater than 3.25. Greater than 3.25 means find this area. How do we find this area? This distance is that times 1/9. Again, remember, this 9 here is said normally distributed between 0 and 9 minutes. Means this 0 and 9 are given. So if 0 and 9 are given, this rectangle, if this distance is 9, then this has to be, this height from here to here has to be 1/9. Why? Because the outcome of rectangle always must be 1. So in that case, first we create this, the distance, horizontal distance is 9, this is 1/9. And when they ask us to find probability of x greater than 3.25, means find this area, you just take this distance, multiply by 1/9. Same thing here. They want us to find x between these two numbers. Okay, so you subtract it and multiply by 1/10. 46 to 56 are given in the problem. That is indication that this length is 10. If this length is 10, then the height has to be 1/10 in order to have the area of 1. All the problems here, we are using the calculator. Like here, for that one, they ask us to find this area. One end is minus 0.83. Do I have the other end? No, but you always use what? It could be positive 10 or any other number. It could be even 5. It doesn't matter what number you put here. You could even put 10 here if you want. As long as it's greater than 3 or 4, when it's getting close here, the area is almost 0. The same thing here. In these problems, both ends are given. So all you need to do is one is the negative is on the left, this on the right. So you see that the calculator would estimate the probability easier than using the table. In this example, the area is given and they ask you to find the z. Z is a question. So in that case, you use the second inverse norm. You put the area. By default, the mean is 0, standard deviation is 1. The calculator would do the z for you. See, they also ask you if you want to use a table, but we don't need to use the table anymore because you have a calculator. And tables are not easy access, but calculator you always have it with you. So that's the whole way of doing it. See, all these problems, we are using the same formula. This one, area is given, find the z. These problems are all using this formula, second inverse normal. See, this table, we don't really need it. And the rest is all multiple choice questions that I have the answer for you. The key is at the end here that you could use.